In this video, we'll be discussing our probability and statistics 2 for October-November 2021, paper 6-1. Okay, so let's start with question number 1 here. It is known that the height in meters, right, of tree at a certain kind has a distribution of this one. So basically, you can say it is normally distributed. And then there's a scientist taking a random sample of 25 trees of this kind of the sample mean, which is a h bar of the heights. So they want us to state the distribution of h bar giving the values of any parameter. So we want to investigate the distribution of a sample mean, right? Basically, we have to see what is our population. So from here, right, this is actually our population. So we are having a normal population in this case. Okay, this is our normal population. Our population is normally distributed. This is the population mean, and this is the population variance. All right, so according to what we learned earlier, right, if we want to know what is the sample mean, the distribution of the sample mean, it depends on the population distribution. So our population is normal, therefore our sample mean is also normally distributed. Okay, therefore our sample mean is also normally distributed. And how to get the mean here? So the mean for a sample is actually the same as the population mean, which is the mu, and you can write as 12.5. When you want to calculate the variance, right, for a sample mean, so the formula for sample mean is you have to take the population variance divided by sample size. This is the population variance. Therefore, for this case, we are going to take the population variance, which is 10.24, divided by the sample size. So what's the sample size in this case? They are taking a sample with 25 trees, right? So the sample size will be 25. Therefore, you get 0.4096. Okay, either you can keep it in the decimal number or you can just put it as a fraction form if you want. So you need to show three important things here. The first one is you have to show that the sample mean is normally distributed. After that, followed by the mean of a sample mean, which is same as the population mean. And after that, you have to show the value of sample variance. And sample variance will be equals to population mean divided by sample size. So this is what you need to show in part number 1A. Alright, and after that, let's proceed to part number 2. They want us to calculate this probability. Alright, so to calculate the probability here, since we already know that the sample mean is normally distributed, right? Therefore, to calculate the probability, you need to change it become Z. How to change it become Z? You have to standardize it. So you have to take 12 minus the mean. What is the mean of the population? So the of the sample mean. Mean of the sample mean is this one. We already calculated just now, 12.5. Divided by the standard deviation. So divided by standard deviation. Variance is 0.4096. So standard deviation will be square root of 0.4096. Alright, so this is the standardization process. Okay, then you have to take 13. Same thing happened here. You have to standardize it minus the mean divided by standard deviation. And therefore, you'll get the value of Z. Okay, the value of Z will be negative 0.781. Please make sure that the value of Z, right, you find it up to 3 decimal places. Okay, so that you can get the most accurate answer from the table that we have. Right, so this one must be 3 decimal places. So it will be negative 0.781 until positive 0.781. Okay, so for this graph, for this probability, if I want to find out the probability here, basically what I do is like, the center is a 0, right? And the mean is a 0 here. So negative 0.781 and also positive 0.781. So by right, to find out the probability, we are interested to find this particular probability. How can we find out this particular probability from the table, from normal table in the MF19? So to find out this probability, there are many ways for you to find it out, right? So I will show you one method here, the method that I'm using. So first of all, to find out this shaded area of the probability, I will take this whole area here. So the black color one, I try to highlight it by using the black color area. So if I want to take this area, right, it can be written as Z smaller than 0.781. Then I have to minus this small area. Okay, minus this small purple color area here. so that I can get the shaded area that I have, right? So the black color minus the purple color, then I get a shaded ring color area. So the purple color area, if you try to write out, it should be z smaller than negative 0.781. Okay, so this is not only way. There are many different ways that you can find out the probability. Some students, they will want to use 1 minus the probability of z more than 0.781, then minus also z smaller than negative 0.781 also can. So there are many different ways that you can find out the probability here. Okay, so for me, usually I'm using this method, right? Okay, then after that, I will try to find the probability from table. Z smaller than 0.781, so we can have a look for our normal distribution table. 0.78, this is our 0.7, then 8 is here, therefore we should look for this particular value. This one, right? 0.78 and then 1. 1 means 3. It means that you have to take the 7, 8, 2, 3, add the 3 at the last digit, so you're having 0.7826. Okay, so we go back to our solution here. Okay, what's the answer that you should put it here? It should be 0.7826. Just now we get 0.7826. Then minus this particular purple color area, right? It is actually equals to 1 minus 0.7826. Because this small area is equals to the large area here, this one, okay, on the right, the small area on the right. So it is equals to 1 minus the area that we get from the normal distribution table. Then continue from here. If you didn't do any careless mistake, by right, you're having 5652, 0.5652. And of course, I want to correct it to 3 significant figure, then it should be 0.565. Okay, so this is how we solve question number 1. Okay, so we are now at question number 2. The number of inquiries received per day for customer service desk has a Poisson distribution. So highlight the keyword Poisson. Okay, with the mean 55.2. If more than 60 inquiries received in a day, the customer service desk cannot deal with them all. So use a suitable approximating distribution. Highlight the keyword approximating distribution. So for this question, we have to change Poisson, become some other thing else. Okay, in our syllabus, for Poisson, right, we can only change it become normal when the lambda is more than 15. So I think this question is very obvious, right? When your lambda is more than 15, you have to change your Poisson, become normal distribution. And they want us to find the probability that the customer service desk cannot deal with the inquiry that are received. Okay, so since the keyword are very obvious, right? So we can start with our Poisson distribution first. And we know Poisson distribution is having the mean or lambda 55.2. Then we can change it become normal. I think it's quite obvious that the lambda is more than 15, therefore we can change it become normal, where the first parameter in the normal is mean, which is also 55.2, and the second parameter should be variance, it is also 55.2. Because for mean and variance is in Poisson distribution, they should be the same. Alright, therefore when you want to write out in the normal distribution, mean and variance should be having the same value as well. Then we'll start with the probability here. We want to get the probability of the customer desk, service desk cannot deal with the inquiry. They said if cannot deal with inquiry means that you're having more than 60 inquiry in a day. So that means more than, you put greater than, not included 60. So more than 60. Alright, so for your information, before you can calculate the probability, right, Poisson is discrete random variable. And normal is actually continuous random variable. Alright, then if you want to calculate the probability from discrete to a normal to a continuous variable, you have to apply continuity correction. Right, then for continuity correction, for this case, it should be greater than 60.5. Again, to know the detail of doing the continuity correction, I will put a comment. Okay, maybe at a link at the comment part, then maybe you can have a look for the particular video that explain about the continuity correction. Right, so this is what we have here, continuity correction. Usually for continuity correction, it's plus or minus 0.5. So there's a small technique that you can try to remember. When do I need to plus 0.5? When do I need to minus 0.5? So again, I'll put the video link at the comment part. Right. Then let's continue further. When we are having x greater than 60.5, after you do the continuity correction, Now you are having normal distribution, right? Therefore, to calculate the probability, you have to change it become Z. That means you have to standardize it. So you take 60.5 minus the mean. So I'm having minus the mean, minus 45.2 divided by standard deviation. So divide by square root of 45.2. Okay, then try to get the value of Z. Correct to 3 decimal places, it should be 2.276. Then we'll look for the probability. Okay, so 2.276, looking for 2.2, this is 2.277 is somewhere here. Okay, and then 6 should be this one, right? So what does it mean in this question is, or in this table is, you have to take 9884 plus 2 at the last digit, so you're having 9886. So go back to our step here. So Z greater than 2.276, I have to take 1 minus 0.9886, because for the table, all the value from the table that we get, right, it is actually smaller than Z smaller than a particular value. So Z smaller than 2.276 is 0.986. If you want to take greater than, you have to take 1 minus, right? And from here, by right, you should get answer 0.0114. So this answer is already in 3 significant figure. Yeah, so this is how we solve question number 2. Okay, so let's discuss question number 3. There's a random sample of 75 people, 75 students in a large college was selected for a survey. So 15 of these students say that they own a car. So from the result, an approximate 8 alpha percent confidence interval for the proportion of all students who own a car was calculated. So we are having something related to confidence interval for proportion. Okay, and then they're telling us that the width of this interval was found to be 0.162. So highlight the keyword width. For any confidence interval for proportion, right, to calculate the width, you have to take the upper limit minus the lower limit. So this is your lower limit, P minus Z, then square root PQ over N. This is your lower limit. And the upper limit will be P plus Z, then square root PQ over N. So by right, you should know that if I want to take upper limit minus the lower limit to get the width, right? So the width formula that we have is actually, so you try to take this upper limit minus the lower limit here. By right, you will have 2Z, then square root PQ over N. Okay, so this is a width formula for a confidence interval for the proportion. Okay, all right, so before we can calculate the confidence interval, they actually interested to find out the alpha, the value of alpha. They want to know what is the percentage for alpha here. Okay, right, so first of all, I need the value of P and also the value of Q. So how to get the value of P? So in P, right, it is actually the proportion for the student who own the car is 15 divided by 75. So we get a very nice number for the proportion here. It should be 0.2. Okay, and then for your information, if you want to find out the confidence interval, right, the alpha percent basically means that the center alpha percent for a normal graph. So as an example, if I say I'm having a 0 here, okay, so by right, this center area here, this center area is the alpha. So it is actually alpha divided by 100 because our alpha is in percentage. So I'm having alpha over 100 for the center part here. So what happened to the side here? So to the area of this side, we are going to take 1 minus alpha over 100 divided by 2. So 1 minus alpha over 100 and divided by 2. Alpha is percentage, so to change it become probability, I make it become divided by 100. And then for this part, I have to take 1 minus alpha divided by 100 divided by 2. Same thing happened here. You should have 1 minus alpha over 100 divided by 2. These two areas are symmetrical to each other, right? So their area should be the same, or the probability should be the same. And the Z that separate, okay, the center and the top part is the Z. Then this part should be negative Z. Okay, so the value that we find out is actually the confidence interval that holds for the alpha percent. And now they already give us the width. So what's the width for this value? It should be 0.162, right? So they are telling us that the width equals to 2. Then the z, I don't know what's the z. I need to find out. When I find out the z, only I can know what is the alpha. I want to relate the z with the alpha here, right? So I need to find the z first. After that, only I can use the value of z to find the alpha. Then for square root pq over n, so your p is 0.2, q is of course 0.8 lah. 1 minus 0.2, you get 0.8, then divided by n. So what's n here? Sample size. So sample size is 75 students. Okay, then try to use calculator. By right, you should get the value of z. For me, I'll get the value of z up to 3 decimal places because all the value that we have in normal distribution table, all the value of z, okay, the accuracy is up to 3 decimal places. Alright, so when I want to find out the z from normal distribution table, I will put it up to 3 decimal places, which is 1.754. Alright, then now I try to link the value of z with the alpha here. Okay, so if I want to form one equation for this area, for this probability, how can I write it out? Okay, so I want to form an equation for this blue color area so that I can link the value of z with the alpha. Okay, there are many ways. Or some students, maybe there are many ways. So some students, they want to use the upper one, the upper value here, or maybe some students, they want to use the lower one, this one. Also can, up to you. Okay, so some students want to use this one. If you want to use this one, it will be z smaller than 1.754 equals to 1 minus alpha divided by 100 over 2, then add alpha divided by 100. But for me, I scared that I will do careless mistake or whatsoever later. So I found that this one, later when I want to simplify, I have to be very, very careful. Okay, so for me, I'm not going to use the smaller one. I will use the larger one, the dark blue color that I draw in the diagram. Okay, so if I want to form an equation by using the dark blue equation, it will be z more than 1.754, because more than z more than this value, right, 1.754, the answer is equals to 1 minus alpha over 100 divided by 2. Okay, so I write better, 1 minus alpha over 100 divided by 2. Okay, all right, then now I need to find out the probability for z greater than 1.754. So what's the value for z minus 1.754? Go to the normal table, looking for 1.754. 1.75 is here, and then 4 is this one. So we are taking 0.9599 add 4 at the last digit. So 9599 add a 4 at the last digit here. By right, we should get 9603. Okay, yeah, so we go back to our step here. The value that we get is z smaller than. So we are looking for z greater than. Therefore, you have to take 1 minus 0.9603. And this area is equals to 1 minus alpha over 100 divided by 2. Okay, try to simplify your answer. So you're having 1 minus alpha over 100. Bring the 2 over here, become multiply. You should get 0.0794. Then try to simplify your alpha slowly. By right, you will get the answer, which is 92.06. Okay? And if you have to look for the question one more time, you can see that the question is asking for alpha correct to 2 significant figure. So my final answer for alpha should be 92 only. So correct to 2 significant figure. So our alpha is actually 92%. Okay, so this is one way to get an answer. So if you want to use some other area that, like what I showed you just now, right? If you want to use this small area here, the bigger area here, z smaller than 1.754, then you can do the same thing, where you let z smaller than 1.754, the probability is equals to 1 minus alpha over 100 divided by 2, then plus alpha over 100. Okay, then z smaller than 1.754, the answer is 9603. So you can put 0.9603 equals to 1 minus alpha over 100 divided by 2, then plus alpha over 100. Then you continue to rephrase the equation and get the alpha. So by right, your alpha should be also 92, correct to two significant figure. Alright, so there are options for you, which area you want to refer to and you want to simplify and get the value for alpha. Alright, yeah, so this is how we solve question number 3. Okay, so question number 4. We are given the probability density function x for the x. This is a probability density function, and then the value of x is from 0 until 3. And first question, they want us to find out the probability for x smaller than 1.2. So this is a continuous random variable. Therefore, to find the probability, we have to apply integration. Okay, so for z smaller than 1.2, right, x smaller than 1.2, we are going to consider the integration of 0 until the value 1.2. We are interested to find out the area, okay, between 0 until 1.2, because the area under the graph is basically the probability, right? So integrate from 0 until 1.2 for the function given 1 over 18, then 9 minus x power 2. Okay, so 1 over 80 is a constant. I prefer to take it out first. Then integrate 9, I will have 9x. Integrate x squared, I'm having x power 3 divided by new power 3. Then substitute in the value 1.2 and 0 into the value x. Okay, then 9 multiplied with 1.2, I will get 10.8. Then minus 1.2 power 3 divided by 3. Substitute a 0 inside the equation. I'm having everything 0. Okay, then try to just simplify the answer. By right, it should be 71 over 125. Okay, or you can keep it in the fraction form. If you don't want, then you can just put it as a 3 significant figure answer. So it should be 0.568. Okay, so this is the answer for part A. Then let's proceed to part number B. For part number B, they want us to find out EX, expected value of X. So for information, to use the expected value of X, right, the general formula is you have to integrate the value for all X for the function. And before you do the integration, you have to actually multiply the X with the function to get the expected value of X. Okay, so according to our example here, or our question here, what do we have? Our X lower limit is 0, upper limit is a 3. Then I have to multiply the X with my original function, 1 over 18, then 9 minus x squared. Okay, so I have to simplify everything first before I can integrate them. So personally, I will, for this question, I think before the integration, you need to multiply the x in the function. Okay, so if you multiply the x in the function, then you're having 9x minus x power 3. Okay, then only we start the integration. So I'm having 1 over 18. So 9x squared divided by 2, x power 4 divided by 4 with 3 and also 0. Okay, again, substitute the value in. 9 over 2 multiply with 3 squared. 1 over 4 multiply with 3 power 4. Substitute 0, everything here you'll get a 0. And I try to use calculator, help me simplify the answer. So if you didn't do any careless mistake, by right it should be 9 over 8, or it should be 1.125. So 1.125 is not a very long decimal number, right? So you keep it in this form, still okay, we will still accept. Okay, unless you are having a very long decimal number, then only you correct it to 3 significant figure. Okay, so that's the method how we actually find out the expected value for x in a continuous random variable. Alright, then let's proceed to part C. So they are telling us that the median of the x is actually m. So they want us to show that m minus 27, m plus 27 equals to 0. They want to prove that we get this equation if they tell us this information. All right, then again, usually how are we going to find the median? Yeah, so according to what we learned in AS Stats Chapter 1, median basically cover 50%. I mean, median is in the center of the whole set of data, right? So if let's say you try to look at the ratio from the smallest value until median, it actually covers 50% of your data. So in continuous variable, the idea is if you try to integrate the lower limit, okay, until the median for the function f, you should have 50%. So 50% in probability means 0.50. Or you can integrate from median until upper limit or the largest value of x for the function fx, you also get 50%. So you can use either one of these knowledge, all right, to find out the equation, to prove for the equation that they want us to show, right? Okay, so I will use the lower limit one because lower limit for our case here is 0. So it's easier for us, right? So I will use 0. So I want to integrate from 0 until m for my function 1 over 18 and then 9 minus x squared. It is equals to 0.5. Okay, then now we integrate. Integrate 9, you get 9x. Integrate x squared, you're having x cubed divided by 3. Then from m until 0 equals to 0.5 as well. Okay, then slowly substitute in the value here. So you're having 9m minus 1 over 3 m power 3 minus substitute 0 inside, you're having 0 minus 0. Then you have 0.5, which is half. Okay, bring the 18 over. So bring this 18 over here, become 18 divided by 2. So 18 divided by 2, you have 9. On the left hand side, you're having 9m minus 1 over 3m cubed. Then again, if I want to get rid of the denominator 3, I multiply the whole equation with 3 again. So I'm having 27m minus n power 3 equals to 27. Then rephrase your equation. You successfully get what they want you to show. Okay? Yeah, so this is how we get the equation. All right, by using the concept that if I integrate from the lower limit until median, it covers actually 50% of the data. All right, so this is how we solve question number 4. Okay, question number 5. The proportion of the people having a particular medical condition is 1 in 100,000. Okay, there's a random sample of 2,500 people is obtained. Then the number of people in the sample having the condition is denoted by X. So state with a justification the suitable approximating distribution for the X, giving the value of any parameter. Okay, so you can see that in this original question, right, we are having a large value, 2,500 people. And after that, we are having a proportion. I don't know whether you can see or not. 1 in 100,000, it is a proportion. And this is n. Okay, it is like a sample size like that. Then if you are having n and p, right, you should know that original distribution should be binomial. Okay, that means your original distribution is binomial for the x, yeah. So I'm having 2,500 and the p is 1 over 100,000. When you're having originally binomial distribution, what is the approximating distribution for x that you can have? So of course, from binomial, right, we can have normal, and we actually can have also Poisson. Then for the normal one, right, you should know that it belongs to AS diverse. Okay, then A to 1, we are having binomial to Poisson. So for this binomial distribution, you should have a Poisson, which is change to become Poisson distribution. But what is they are asking you with a justification. That means you actually have to figure out whether before you change binomial become Poisson, right? Is the binomial distribution fulfill the condition or not? Okay, so you have to show them the justification here. Okay, then you can write the n is equals to 2,500 which is more than 50 as stated in the condition. And after that, for n times p, if I take n times p, it is n times p. And the value that you get for n times p is 0.025, which is also smaller than 5, and p smaller than 5. Okay, as stated in the condition, to change a binomial become Poisson. Therefore, you can write in this way. So since n is greater than 50, and p is smaller than 5, therefore, you can change binomial become Poisson distribution. Okay, so for Poisson is 0.025. Okay, all right. So for justification, you have to make sure that you show clearly and also tell them clearly what is the condition. Okay, besides the condition, you also need to use the value in the extent of the question. So like for this one, n greater than 50. In this question, we are having n is 2,500. Then for np smaller than 5, in this question, you calculate np and I get 0.025. Alright, so you have to justify it by showing the values, related values are in the extent of the question. Okay, alright, so this is how we solve part number 1. And let's proceed to part A2. Use the approximating distribution to calculate the probability of x greater than 0. Okay, so to find the probability for x greater than 0, for your information, binomial is discrete random variable. Poisson is also discrete random variable. Both of them are discrete, therefore continuity correction is not needed. If you're having discrete changing to continuous, then only you need continuity correction. But for this one, both are discrete, so no continuity correction is needed, yeah? Then I can directly find out the probability by using Poisson. So to find the probability for x greater than 0, you can include x equals to 1, x equals to 2, x equals to 3, until x equals to infinity in Poisson. So to make the steps shorter and also easier, we have to take 1 minus x equals to 0 to get the probability, right? So I take 1. What's the formula for x equals to 0 in Poisson? E negative lambda. So our lambda is 0.025. Then lambda power 0 divided by 0 factorial. Okay, so from here, try to press calculator a little bit, then you should be able to get the answer 0.0247, correct to 3 significant figure. Yeah, so this is how we get the answer for A2. Then let's proceed to the next part. Okay, for part B. Okay, they're telling us that the percentage of people having different medical condition might be 30%. So a researcher suspects that the true percentage is less than 30%. Highlight the keyword less than. Okay, less than is an important keyword. In medical trial, a random sample of 28 people was selected and 4 people were found to have this condition. Use a binomial distribution to test the researcher's suspicion at the 2% significance level. So they already tell you I have to use binomial distribution and run the test at 2% significance level. So when you want to run the test, right, the word less than is a very important keyword to help us to form the alternative hypothesis. Okay, all right, so let's start. For binomial distribution, when you want to run the test, we are testing the proportion. So they are saying that originally we thought that the proportion is 30%, so I put it at 0.30, change it become the probability. Then for alternative hypothesis, the word less than tell us that we are having we want to prove or we want to run the test to show that P is less than 0.30, that means less than 30%. Okay, and in this question, they ask us to use binomial distribution. So what is my n, the sample size for binomial? So I'm having 28 people. And the P, of course, should be 0.3. Okay, then how to calculate the p-value? So to calculate the p-value, we need an observed value. So the observed value is this one, 4. observed value. So to calculate the p-value, you have to use the observed value for the calculation. So I'm having x something with 4. So what's the sign that I should put here? Should it be smaller equal or greater equal? Okay, so a simple method to decide is this one. You can have a look for the alternative hypothesis. So if your alternative hypothesis is smaller than, then your calculation for the p-value or the probability should be smaller equals to. Same direction as the alternative hypothesis. Okay, right. Then how to calculate probability for x smaller equals to 4? So you should start from x equals to 0 lah. We are using binomial, right? So x equals to 0 is 28C0, 0.3 power 0, 0.7 power 28. This is x equals to 0. Then I want to calculate x equals to 1. So 28C1, 0.3 power 1, 0.7 power 27. Okay, so we try to complete the calculation until x equals to 4. So this is 0.3 square, 0.7 power 26. X equals to 3. Then x equals to 4. We should stop at x equals to 4 lah, because the calculation here shows smaller equals to 4, right? So we should include the 4 and we'll stop here. Okay, so try to press calculator a little bit and see what do we get here. So by right, you should get 0.474, correct to 3 significant figure. Okay, so for your information, this particular value here, we are calling it as p-value. Okay, so after you calculate probability by using the observed value, right, you need to make a conclusion. So how are you going to make a decision or conclusion? You actually have to compare the p-value with alpha. Our alpha is 2 significant figure. Okay, so what does it mean? Okay, so I just show you again one diagram here, but it is not the correct diagram. Please don't show this in the exam, but it is for visualization purpose. At least you can imagine a little bit, yeah? Okay, so I'm having 0 until 28, and this is the x. Okay, the significance level tell us how big is our rejection region. So 2% is our rejection region, and our rejection region is on the left-hand side because the sign is smaller than in alternative hypothesis, which means that I'm having my rejection region on the left, and this particular area should be 0.02. 2%, right? So this is 0.02. Then you have a look for the diagram for the value that you get. The p-value you get is 0.0474, which is larger than 0.02. So that means all the 0.0474, the area that you want to show, right, it should be larger. So that's why it should be larger than 0.02. And this is the value 4. And you can see that the value 4 falls under the white color area, right? So this white color area is acceptance region. That means if you want to make a conclusion here, it should be acceptance. That means you do not reject the null hypothesis. Okay, but before you write out this decision, you have to tell them a reason. So you can say that since the p-value, which is 0.0474, is greater than alpha, which is 0.02. And if the p-value is greater than alpha, the value of x actually falls under the acceptance region. So again, this diagram, please don't show in exam because this is not a correct graph, right? So I will want to erase it here. Okay, so this is the reason. Since you compare the p-value and the alpha and you realize that, oh, p-value is more than the rejection region, therefore the conclusion or decision that we make is this one: do not reject the null hypothesis. Please write out one conclusion sentence in the extent of the question. So you can tell them that you didn't reject the null hypothesis, right? That means there's insufficient evidence to show that okay, you can copy the question, the sentence from the question to show that the percentage, okay, of having a different medical condition is less than 30%. Okay, so besides writing out the decision that you made, you also need to write out one statement of conclusion that is in the extent of the question. Okay, yeah, so this is how we solve question number 5. Okay, so question number 6. We have a random variable t denotes the time in seconds for 100-meter race by Tanya. So t is normally distributed, highlight the keyword normally distributed. We are having the population mean and also the variance. So there's a random sample of 40 races run by Tanya gave the following results. So this is what we have here. Calculate unbiased estimates of mu and also the variance. Alright, so just to recall back, if you cannot remember the unbiased estimates formula for mean and variance, you can actually get it from the normal, or from the formula booklet, yeah. But I'm not so sure where is it. Let us have a look. Under this part, yeah. Yeah, so you can see that this is our unbiased estimator for the mean and also the unbiased estimate formula for the variance, right? You can just get it from here. Right, then let's continue further. So again, I will just want to write out the mean. So to get the unbiased estimates for the mean, it is summation of x divided by n in general. And then for the variance, it should be 1 over n minus 1. Then summation of x squared minus the summation of x whole thing square divided by the n. Okay, so to me, I think this question is quite straightforward. You just need to substitute in the value that is provided for you. So to calculate the unbiased estimate for the mean, the formula should be 560 divided by 40. Then the value that you get should be 14. Okay, then how about for the variance? So for the variance one, you just substitute in the value that is available here. So 1 over n minus 1. So you should have 39 here. Summation of x squared is 7850 minus the summation x squared. So that means I'm taking 560 squared divided by the original n. So the original n is 40. Okay, then again, you can keep your answer in a fraction form, then 10 over 39. I will keep this in the fraction form, right? Because I expect that this is part A, so I expect that we might want to use back the result here in part number B. So to make sure that I get the most accurate answer, what I want to do is that I will keep the variance in a fraction form so that later I can get everything nicely in the most accurate way, right? Yeah, so this is what we have for part A in question number 6. So let's have a look for part B. Just now we're having T, right? And now we're having the other random variable S by Suki. So Suki has an independent distribution also normally distributed. So by using your answer in part A, find the probability in the randomly chosen 100-meter race, Suki's time will be at least 0.1 seconds more than Tanya's time. So we want to try and write out this particular sentence into a symbol form. We are interested to find the probability. Suki times means S. You are seeing the word more than, right? So means Suki's time more than 0.1 second Tanya's time. So that means you're having 0.1 plus Tanya's time. Okay, so Suki's time is at least 0.1 seconds more than Tanya's time. So that means you take Tanya times plus 0.1, Suki's time is still more than that. So something like that, okay? So this is the probability that you want to find out later. But again, for your information, right, we can't find out the probability if both sides of inequality are having the variable. What we need to do is we have to move the t over, become s minus t greater than 0.1. Alright, so the original question want us to find this probability, but we cannot find out if we have both sides with random variable. I will move all the random variable to one side. So I will try to find out the distribution of s minus t first before I can do the calculation of probability. Okay, alright. So first of all, I want to find out the probability, the mean of s minus t. So the Suki's mean time is 14.2. Tanya's time is 14, the mean. If you can't remember, you have a look for the part A just now. Okay, 14. All right, then the mean for this variable is 0.2. Then how about for variance? To calculate the variance, it will be s minus t. So Suki's variance is 0.3. For variance, there's no minus, therefore it is always a plus. Yeah. Then for plus the variance of t. So again, the variance of t that we get just now is 10 over 39. So I want to put it here. So that's the reason why I want to keep it as a fraction form. So that in this calculation for this variance, at least I still can get a nice value. So 217 over 390. Okay, so I keep it in the fraction form again because for the calculation of the probability, I will want to use the original variance value. Okay, so S is normally distributed. So in part A, we also know that T is normally distributed. Therefore, S minus T is still normally distributed. So you can write as normal distributed. First parameter is the mean. The second parameter is variance. Okay, so this is what we have. All right, then let's go and get the probability. So in this question, they are asking S at least, oh, sorry, I think I made a small mistake here. At least should include the equal sign, at least. Okay, so this one should be S greater or equals to 0.1 plus T. But actually, this is normally distributed. So no matter you put equal sign or no equal sign, it doesn't affect your final answer. They are the same actually. Because normal is a continuous random variable. So equal or not equal sign will not affect our final result. Okay, right, so I'm having this as the original question. To find the probability, I move all the variable to one side, S minus T greater than 0.1. And I know that S minus T is normally distributed, right? I have to change it become Z. Then how to change it become Z? You have to standardize your variable. So you take 0.1 minus the mean, which is 0.2, divided by standard deviation. So standard deviation is square root variance, 217 over 390. Okay, then again, correct. Find out the Z correct to 3 decimal places. It will be negative 0.134. Okay, then this area, negative 0.134, right? This is negative 0.134. Okay, we are interested to find out this area. But in the normal distribution table, we are not having the negative value of Z. So you have to try and imagine this area same as what area in positive 0.134. So let's say this is positive 0.134. So it should be the same with this one. Okay, so in short, Z is smaller equals to 0.134 lah. Then you try to find the answer from the normal distribution table. 0.1 is this one, 3 is this one, 5517, and then 4. 4 means you have to add 16. So you take 5517 plus 16 here. So what's the value that you get? If you have 5517 plus 16, you should have 5533. Okay? Yeah, so we go back to our steps here. Okay, so this area should be 0.5533. And then I want it to be safe. So usually for me, I will just keep it into 3 significant figure, which is 0.553. So this is how we solve the question number 6. Okay, then let's proceed to question number 7, which is also the last question for this paper lah. Okay, so we are having the mass in gram for apple of the apples from a certain farm. Mean and also standard deviation 5.2. The farmer says that the value of mean should be 64.6. Then there's a quality control inspector claims that the mean is actually less than. So highlight the keyword less than again. Okay, right, then in order to test his claim, so we are talking about test. So the word less than basically is a keyword to help us to form the alternative hypothesis. Right, so in order to test the claim, he chose a random sample of 100 apples from the farm. Okay, the mean mass of the 100 apple is found to be 63.5. So the 63.5 here is the mean for these 100 apples. Therefore, you should know that it is a sample mean. They want us to carry out the test at 2.5% significance level. Okay, so for this question, when you want to run the test, right, we have to use normal distribution. If you read the question, they didn't tell us that this whole question is about normally distributed, is normally distributed, but we'll have a large sample value, the large sample size, which is 100. So when you're having a large sample size, regardless to the distribution of the population, right? Okay, according to the central limit theorem, it should be approximately normal for the sample mean, all right? Okay, so now let's start the test. So first step, you have to form the null and also the alternative hypothesis. So for the null hypothesis is you want to test the mu. You believe that the mu is 64.6 gram. Okay, then to carry out the test, you want to have the alternative hypothesis. The word less than is a keyword to help us to form the alternative hypothesis. It should be mu less than 64.6. So this is the first step. All right, then second step, we want to get the critical value if you want to use the critical value approach. So for this critical value, it is actually the Z. The critical value is actually the value of Z that separate the acceptance and also the rejection region. We are having less than in alternative hypothesis. That means our rejection region is on the left-hand side. Okay, and our rejection area is the sigma, which is 2.5%, 0.025. Sorry, what happened here? So it should be 0.025. Okay, so this particular value of Z, we call it as critical value. So how to find the critical value? You can find out by using the big area here, 0.975. Okay, because total up should be 1. So 0.025, you cannot use the 0.025, the small area, to find the Z. Therefore, you have to use the large area here. So you're looking for 0.975. So to get the value of Z, usually I will look at the shortcut formula at the bottom part and see whether there's the area that we want. Hey, what happened here? What it didn't show. Okay, so I don't know why. The table didn't show out the value of Z here. So if we have a look, right, look for 0.975. By right, there's another row of value Z here. So the 0.975 will show you the value of Z, which is 1.96. So you can use the value of Z directly from here. Okay? Yeah. Then if I come back to our question here, I know that the Z should be 1.96, but 1.96 should be on the right-hand side, positive. But I'm having a value Z here. Therefore, the 1.96 is actually negative value, so it should be negative 1.96. Okay, so from here, I get my critical value, which is equals to negative 1.96. Okay, then now, I want to get my test statistic. So how to get the value for test statistic? We are using the formula of sample mean minus the population mean divided by standard deviation over square root n. So what's the sample mean here? It should be 63.5 minus the population mean 64.6 divided by the standard deviation given is 5.2 over square root 100. Okay, then you try to get the test statistic, it should be negative 2.12. Okay, all right. Then after you get the test statistic, you get a critical value. Then now you want to make a decision. And before you want to make a decision, you need to have a look where is your test statistics located. So the test statistic is negative 2.12. If you try to put it inside the graph here, this critical value is negative 1.96, right? So to get the test statistics fall under this part, which is negative 2.12. And you can see that the negative 2.12 falls under the rejection region, right? Okay, Negative 1.96 is here, so by right, according to the value of the z, negative 2.12 should be less than negative 1.96. So it falls under the rejection region part. Okay, so from here, you can make the decision where you have to reject the null hypothesis. Okay, so before you make the decision, you have to tell them the reason first. So since the test statistic, which is negative 2.12, is less than the critical value, which is negative 1.96. Okay, therefore, we reject the null hypothesis. All right, then besides that, this is a decision that you make. Okay, so besides that, you also need to put in a conclusion statement in the context of the question. So you can tell them that there is sufficient evidence to show that the mass of the apple less than 64 gram. Okay, so this is how we run a complete test, all right, by using the information provided. Okay, so let's proceed to the next part, 7b, which is the last part of the question also. Then now they are saying that, okay, another test of the same hypothesis at the 2.5% significance level, they are still the same, just that we are using another sample of 100 apple from the same farm is carried out. Given that the mu is 62.7, they want us to calculate the type 2 error. Okay, so let us talk about the type 2 error first. So the definition for type 2 error, right, is actually you accept the null hypothesis but the null hypothesis is false. Given that the null hypothesis is false. Okay, then how can I calculate this probability? For accept null hypothesis, we need to find out the acceptance region. Okay, but in this question, we don't have the acceptance region. All right, so where's the acceptance region and how should we find it out? Okay, we just recall back to the diagram that we have just now in part A. So part A, we know that this is our rejection region, right? And this is 0.025, this is 0.975, and this is the value of Z, the critical value. Critical value is also Z, which is negative 1.96. So the highlighted area here, the shaded area here is the rejection region. If we successfully find out the rejection region, then we can find out the acceptance region later. All right, yeah, so this is what we plan to do lah. Okay, so from here, I will write out first. So try to imagine, if I want to write out an inequality for the rejection region, how should it look like? It should be Z smaller than negative 1.96. So when your Z is smaller than negative 1.96, we basically reject the null hypothesis. So how can you calculate the Z? From a random sample, okay, by using the sample mean. So the test statistic will be sample mean minus the population mean divided by standard deviation over square root n, smaller than negative 1.96. Okay, so by trying to move all the value here and there, right, you should get an inequality in terms of x bar, which is 63.5808. That means, later, if you carry out any test, right, if you find out that, oh, the sample mean is less than 63.5808, then you can reject the null hypothesis. All right, so this is the rejection region. Therefore, from here, what is the acceptance region? So rejection and acceptance region are having the opposite sign. So if this is rejection region, then the acceptance region will be mean x greater than 63.5808. This is your acceptance region. Then again, for this acceptance region, I will keep it as long as possible. Okay, because I want to use this to calculate the type 2 error later to get the most accurate answer. Right. So let's start. I want to calculate the type 2 error now. Like what I showed you just now, the formula for type 2 error is, the definition is, accept the null hypothesis when the null hypothesis is false. Okay, so accept null hypothesis means you have to put in the acceptance region. So it's this one. Null hypothesis is false. So null hypothesis is false. Now, if you have looked just now, that means your mean, your null hypothesis is not correct. It cannot be 64.6 anymore. It should be less than 64.6. But to calculate the answer, right, they will give you a new value for the mean, which is 62.7. So when null hypothesis is false means that you cannot use 64.6 anymore in your calculation. You have to use 62.7. Therefore, in type 2 error, right, definitely they will give you one value for the mu, which is needed for the calculation of the error, right? Okay, then again, sample mean is normally distributed. So to calculate the probability, I have to change become Z. So you take 63.5808 minus the mean. So you cannot use 64.6, yeah? You have to use 62.7 divided by standard deviation, which is still the same, 5.2. Sample size is still the same, 100. Okay, so simplify the value, you will get 1.694. So I think you should know, like I told you earlier, right? You have to keep your value of Z up to 3 decimal places because the accuracy for our normal distribution table for Z is up to 3 decimal places. Okay, so 1.694 greater than, so I have to take 1 minus, look for 1.694. This is your 1.6, 9 is this one, 9545, then 4 is this one. This value is what? This value is 4. So you take 9545 plus a 4 at the last digit here. So you have 9549. Okay, then go back to our calculation part here. So you take 1 minus 0.9549. Then final answer should be 0.0451. Correct to 3 decimal. Oh, sorry, 3 significant figure. Yeah, so this is how we answer all the 7 questions in this particular paper. And thank you very much for watching the video.